we had seen how every polygon can be considered to be made up of triangles. So we see that each polygon can be made up of triangles. So polygons are made up of triangles, and further these triangles can be made of right triangles. So if I draw a perpendicular from any vertex, so say I draw a perpendicular from this vertex, I draw a perpendicular from this vertex, and I draw another perpendicular from this vertex. So in a triangle, if you draw a perpendicular from any vertex, you get two right triangles. 1 and 2, you get two right triangles. Now, are these two right triangles congruent? Well, here it seems as if they are. Here also they look congruent. But here clearly they are not congruent. So a better question would be, when can I say that these two right triangles would be congruent? Let us see. So we know that in right triangles, we can prove congruency by right angle hypotenuse side, that is RHS. So we can prove congruency by RHS. In these two triangles, let us first make the two right triangles. So we have these two right triangles here. In these two right triangles, I have right angle, that is done. So my right angle is done. I have a common side. They both share a side AD. So AD is equal to AD. So I have a common side also. All I need is that the hypotenuse should be the same. Hypotenuse in this triangle is opposite to right angle, which is AB. Here I have hypotenuse is AC. So if AB is equal to AC, then these two right triangles will be congruent. So let us do that. So now what I do is I make AB equals to AC. AD is common, the side, and we have 90 degrees. So now these two triangles are congruent by RHS. If you look at the larger triangle, ABC has two equal sides. So it's basically an isosceles triangle. So you can see that if a perpendicular is drawn from the vertex in an isosceles triangle, then I get two congruent triangles. Now if the triangles are congruent, then by CPCT I know that the corresponding paths should also be equal. So we can say that if this triangle is congruent to this triangle, then angle B would be equal to angle C by CPCT. Now triangle ABC, look at triangle ABC, that has two equal sides, AB and AC, and two equal angles, which is angle B is equal to angle C. It's not only for this triangle, but in general, whenever you have in a triangle two equal sides, two angles will also be equal. Let us try to prove this. We say equal sides contain equal angles. So let us say that the two equal sides here are AB and AC. So these are the two equal sides. Now which two angles would be equal? Note that these two sides are meeting at vertex A. So leaving A, the other two angles, which is angle B and angle C. So what I want to prove is that angle B would be equal to angle C. So this is what I want to prove. For that, what I'll do is, I'll draw a perpendicular from vertex A to BC. So let's call this point D and say AD is perpendicular to BC. Now in these two triangles, which is ADB and ADC, what do you see? That AB is equal to AC. AB is equal to AC. The second thing, we know that this triangle, let's call this 1 and let's call this 2. Angle 1 is equal to angle 2, each is 90 degree. So I can say 1 is equal to 2. Then the third thing here is AD. AD is being shared by both these triangles. It is common to both of them. So AD is equal to AD, which is common. So now I have a side, angle and side, and this angle is actually right angle. AB and AC are the hypotenuse. So these two triangles I can say are congruent by RHS, which is right angle, hypotenuse and one side. So right angle, hypotenuse and one side. So triangles are congruent and hence all the paths would also be equal. So I can say that angle B would be equal to angle C. Since triangles are congruent by RHS, angle B would be equal to angle C by CPCT. So I have angle B equals to angle C, and this is what I wanted to prove, that angle B is equal to angle C, and hence I've proved it. Well, for now what we've seen is that equal sides contain equal angles, but the converse of this also holds true. That is, if you have equal angles, you would have equal sides. Now let us try to prove that. So equal angles also contain equal sides. Let us say B is equal to C. So we know that angle B is equal to angle C, and we want to prove that two sides are equal. Now which would be these two sides? Note, angle B and C lie on the side BC, so leaving BC the other two sides, which is AB and AC. So I want to prove that AB is equal to AC. Again, what I'll do is, I'll draw a perpendicular first. From A, let's draw a perpendicular and call this point D. So AD is perpendicular to BC. Now, in these two triangles, what do you see? Angle B is equal to angle C. We know that it is given. So B is equal to C. The second thing is, again, since AD was perpendicular to BC, this is also 90, this is also 90. Let's call this 1 and 2. So angle 1 would be equal to angle 2. Each is 90 degrees. The third thing is AD, which is being shared by both the triangles. So AD is equal to AD, which is common. And so again, these two triangles are congruent by, now I don't have a hypotenuse in this right triangle, so I cannot use RHS. We have one angle, second angle, and third side. So angle, angle, side. So these two triangles are congruent by angle, angle, side. Now once the triangles are congruent, I can say that the corresponding parts are also equal. So let us look at the corresponding parts. So I can say, from here I can say AB is equal to AC. The corresponding parts are equal. So AB is equal to AC by CPCT, which means corresponding parts of congruent triangles. So now we've seen that equal sides contain equal angles, and equal angles also contain equal sides. So we know that equilateral triangle has all three sides equal. So what I know is AB is equal to AC, which is equal to BC. This is what I know. Now, since AB is equal to AC, these are the two equal sides, they meet at A. So leaving A, angle B should be equal to angle C. Equal sides contain equal angles. So I have B is equal to C. These are the equal sides, equal angles. Now again, I know AB is also equal to BC. AB is also equal to BC. So now these two sides, equal sides, meet at B. So leaving B, C and A would be equal. So I can say that C would be equal to A. So angle C is equal to angle A. So I have B is equal to C and C is equal to A. So B would be equal to C, which is also equal to A. Hence I can say that all three angles would be equal. That is, A is equal to B is equal to C. So for an equilateral triangle, I get all angles equal. So an equilateral triangle with three sides has three angles also equal. Now angle A is equal to B is equal to C, we know that. But now let's try to find the measure of each. We know that A plus B plus C is 180 degrees. Sum of angles in a triangle is 180 degrees. Now I can write, instead of this, I can say angle A. B is equal to angle A only, so I can write angle A here. C is also equal to angle A, so I can write angle A again. So I know that angle A plus angle A plus angle A is 180 degree. That is 3 times angle A is 180 degrees. So 3 times angle A is 180 degrees. Angle A would be 180 divided by 3, which is 60 degrees. So angle A turns out to be 60 degrees, and angle A is equal to B is equal to C. So each of the angles in an equilateral triangle is equal and is equal to 60 degrees. So we've seen that equal sides contain equal angles contain equal sides. In an isosceles triangle, we have 2 equal sides and 2 equal angles, and for an equilateral triangle, we have 3 equal sides and 3 equal angles.